Now that we have these basic test cases passing, we can start looking into more complicated test cases. If you look into this test that we did for the play game, these transactions are included once per block. If we check the make move, for example, you will see that it's using this sign and broadcast function from the Stargate client. And this function, what it does, it submits the message and waits it to be included in a block. But in the real world, we can have many users submitting many transactions, or even one user submitting many transactions, and all these transactions can be included within one block. So for that, we are going to use this other function that is useful if we want to send a transaction in broadcast without waiting for it to be included in a block. So we can use this function and try to play a whole game just within one block. So let's see how we can implement this. To achieve this, we'll have to do some small changes in our RPS client. So we can go to the corresponding file, the RPS Stargate client.ts, and we'll add a new function called public async commit broadcast transaction sync. And this is just going to call the function that we saw. This is going to be a uint8 array, and we'll return a promise of responses transaction sync response or broadcast transaction sync response. And what this is going to return is just this. We have to force the get commit client and use the broadcast transaction sync for our transaction. Let's add the corresponding imports. And also from Tendermint build responses. Now we have our function. Let's use it. So the first step to achieve this is defining a whole game sequence. I created this game sequence file in the util directory of our end-to-end tests. You will see that this is just a whole game where we have two players, Alice and Bob, and we have the different rounds. For example, this is a round 1 where Alice chooses rock and Bob chooses paper. So Bob starts winning. And we also have the commitment stage where they submit the hashed move, and also the reveal stage where they send the salt and the reveal move. For this we have the 3 rounds. As you can see, finally Alice wins, so player A in this case is going to win. Here we have the whole game. And now we're ready to add our test. If we go to our playgame.ts, we are going to add here a couple of things. First, we'll need an interface that we are going to call account info. That's going to hold the account number and the sequence for this account. We need this because for each new transaction, we'll have to increment the sequence. When submitted many transactions in one block, for each transaction that the same user submits, it has to increment the sequence. So otherwise, it would not take the it will try to replace a transaction instead of applying sequentially all the transactions that we submit. So we'll see this in the test. We'll create a test called submit many transactions can finish the game in one block. And this is an async function. First one, we are going to create a new game and get the game ID. Game ID from the events. This is straightforward, it's pretty much the same as we did previously. We're going to have a response. This is going to be type of deliver transaction response. Alice is going to create a game. Create game with Alice, Bob, and 3 rounds. Out of fees. We'll look for the event. Get create game event. As you can see, when calling this function, this is already waiting for this transaction to be clear in the block, so that's why we can get the events from the response. And we'll expect the event to exist. And we'll get the game ID from the event. Client, RPS target client. Await, RPS target client, connect. And we'll need also a chain ID for our transactions. This get chain ID, if you're asking yourself where is it coming from, it's from the base target client that we are extending with our RPS target client. There are many Cosmos SDK methods that you can use. So here we restore Alice and Bob accounts info to set the nonce or sequence in our case. Accordingly, when adding many messages in the same block. So we'll have account info and Alice account info. It's going to start with the current state that we get from the client, get account Alice. I will store this as an account info. This get account gets more information for the account, but we actually care only about the sequence and the account number, only those two. So for that, that is good enough. We're going to do the same for Bob. And then we'll define a function that's going to go called get signed transaction. And this we're going to have here this function to sign the messages that can be either a make move because we already created the game, or reveal move, and the type URL as well, type string, and this is going to return a promise of transaction raw And transaction row, we had to import it from types, Cosmos, transaction, P1 data, transaction. And here we'll get the client, the corresponding client, right? Because if we have a player that's Alice, we'll use Alice client to sign Alice's transaction. Otherwise, it's going to be Bob client. Then here we'll update the game index to the created game, the game index of the message. So we set game index is going to be long form number, the game ID that we previously got. Import long from long. For now we'll ignore this TypeScript warning. Doesn't make an effect for our use case. And once we updated the game index for the one that we created, we can return the sign message. Sign message player. It's going to be the signer address. And here in the transaction, you can add all the messages that you want, but in our case, we are just going to add one with the type URL of type URL. It's an input parameter, and the value is going to be the message. We'll define some fees later. And then we'll have to add some signer data. That's where the account number and sequence comes, as I mentioned you previously. So we'll have our account info for the player. We'll need here the account number and the sequence. That's going to be the account info of the player, the sequence +1. In each transaction will increase the sequence, and the chain ID. So we have this function to sign the transactions of the game sequence. Let's define the fees. The fee just going to be, in our case, there's no need to have a minimum fee, so it's amount 0. And the gas we'll use 500,000. And then we'll have our transaction list. Now this is the part where we are going to iterate through all the game sequence that we defined in our utils and use our signing function. So we are going to do round of complete game. This is the game that we defined in our file. And we are going to order this. So for each round, both players need to first submit the commitment, which is a hashed move, and then reveal. If they don't follow this sequence, some transaction is going to fail and we will not be able to finish the game within one block. So for the messages of the commitment, we'll iterate all the commitments and we are going to push this to our transaction list, all the signed transactions for the message and the type URL message make move in this case. And we'll do the same for the reveal transactions. So this is going to be reveal, and this is message reveal. We'll import this. So now we are having all the transactions in our transaction list in the order that we wanted to have them, including the block. So we can broadcast all the transactions to include it within one block, and we'll do for transaction list. We'll await client, and here we'll use our broadcast transaction sync, all the transactions encoded, transaction row encode the transaction row that we have on each of the list, and we'll have to add here a finish to signal finish encoding. So here we are broadcasting each of the transactions in the list, and this will start filling the mempool, and once the proposer is the turn of the proposer, we will include all these transactions in a block. So then we'll wait for the next block. So we'll say initial block height, get block, header height, and the current block is going to be the same as the initial block. And we will wait what current block height is less will equal initial block height plus 1. We will keep updating the current block height with this same function. And once all the transactions are included in the block, we have to check that the game ended. Check that game ended, and Alice won. So we can check the game. It's going to be await RPS get game for the game ID. And here we'll have some validations. Game number. Check that the game ID is the expected one. Player moves. Have all the length expected. Both should have 3 moves. Submitted and revealed. And we can check the score. 0. This is Ali's score. 2 equal 2. And Bob's score should be 1. And we can check the status. Game status. 2 equal player A wins. And finally, we'll increase here the timeout for our test because this will take some time. So increase test timeout. And here this is complaining. Let's see. Okay, this can be undefined if we do this. This should be enough. Cannot undefined. What should we expect? Game not to be undefined. And then safely we can say that this will be defined. We have everything set. Let's see if we are missing something. This is complaining. I think we can actually just put this in the V. I need a comma here. That was the issue. But we anyways not using this V outside. We can do like this. Format. Now everything looks okay. We can run the test now and see if we can finish the game within one block. So to do that, we can initialize a new chain and run our PSD start. And now we can run npm test that will run all our tests. And everything is passing as expected. As you can see in this block, we have all the, if you check the number of transaction results, we see that there are 12 transactions in this block. And this is the block where we played the game and finish it. So this concludes the testing of our repo. If you want to add more test cases, you already have all the tools to add all the possible test cases that you can think of. So go ahead and add them. And we will continue now with the section about debugging.